Do you think most published research findings in, say, mathematics are false?
Mathematics is very different. My model was focused on situations where you have empirical data and inferences based on some sort of statistical testing. In that case, it was testing of hypothesis in a frequencies mode, although you can see the same situation appear if you have a Bayesian or an FDR approach, provided that the same forces operate. In mathematics, it's not an issue of empirical testing and falsification. It's an issue of theorems and consistency of theorems. So I don't think that one could extrapolate to theory of mathematical research. I think that when it comes to fields that maybe in the mathematical physical sciences where there is empirical observation and testing, the same principles would apply.
Yes.
But then the question is, what is the operational environment where this research is being done?
Right. I guess I could comment. I'm in theoretical physics, but obviously we watch the experiments very carefully. And I remember as a graduate student when I first heard some very strong earth-shattering experimental claim. But then I looked at the more senior people, the professors, and they would sort of shake their head and say, that's not going to be right. And I would ask them, well, these guys seem very sincere, hardworking experimentalists. They have, 4 sigma, 5 sigma, result. Why are you confident this is going to go away? And then they would say something like, well, would be very hard theoretically to accommodate that, so that's a little bit of bias. But the general observation which stuck with me was they said, in our field, that at any given moment, there's going to be a 4 or 5 anomalous 4 or 5 sigma result, which is eventually going to go away after people try to replicate it, and it's just that's always going to be the situation.
Right.
And so I think in physics we got used to that, and we don't really internalize belief. We don't update on an experimental result until well after it's been replicated and looked at by lots of different people. And I think other fields could get to that point, but they just need a cultural shift or something.
Of course, and I think that there are differences between the physical sciences and biomedical science. Obviously, the dimensions and the complexity are also not at the same scale, because I can think of zillions of situations in biomedical and immunological research where you get not just 5 sigma but 50 sigma.
Right, but still wrong.
And still it's wrong. And you know that it's wrong because you expect it to be wrong in a confounded environment.
Yeah.
I'm working on a database where we have the whole population of Sweden being involved, and we get p-values of 10 to the minus 100.
Right.
And we know that they're wrong consistently.
Right.
So, and I think another difference is that physics has had a stronger tradition of replication and openness and sharing with the community. So, for example, you have the gravitational waves proving inflation about a year ago.
Yeah, your colleagues at Stanford saw that.
Exactly.
Yeah.
And I think it was less than a year, probably just a few months that it took to find out that it was probably just dust, if I interpret correctly.
Yep, that's right.
So I think that does happen in biomedicine as well. So to some extent, for example, we had the claim that there's alien bacteria that can use arsenic instead of phosphorus.
Oh, right, I remember that, yeah. So that turns out not to be true?
It took a little longer, a couple of years.
I didn't, I didn't follow it so I just heard the claim, and then, okay.
Sometimes it's just the claim that it is. And this is another risk that once a very big claim has been
lodged
made, even when it's thoroughly refuted, it will remain there.
You had a result like that, right? So sometimes even though things were solidly refuted, most people would cite the original paper, which actually
Exactly. So people continue to cite the original Nature paper that carotene would save us from cancer, even though we had 6 very big randomized trials with hundreds of millions of dollars spent to get these results, showing that there's absolutely no benefit from that. So it's not easy to say that we will just wait for science to self-correct itself, which it does happen, and I think that we have to be cautious about allowing some erroneous statements to linger in the literature, and maybe it's even better to be preemptive about not allowing them to
have a SWAT team that goes after quick replication funds or something. Or
that would be nice, and people are really excited about this in biomedicine. They're doing this in psychological sciences.
Yeah, I just saw the there's a big project that just concluded, right, with 100 replication attempts or
With,
something.
I believe, 60-something% not
Yeah,
replicated,
yeah.
although there's question then on what is replication.
I could not tell from the Nature article exactly what that meant, the moderate evidence for, and I'm waiting for the actual.
I want to see
Yeah,
the
I want to see what the
paper.
actual, science article says, so, yeah, very good.